Hey everyone! So every time you stream a movie, shoot off an email, or save a photo, you're interacting with the cloud. It sounds so simple, right? Almost magical. But behind that digital world is a massive, very real physical infrastructure. And today we're going to pull back that curtain and look at the hidden costs of our digital lives.
So, just for a second, what do you picture when you hear the word cloud? Is it something light and fluffy, just kind of floating up in the sky? Well, the reality is a whole lot more grounded. And honestly, it's way more interesting.
Yep, that's right. The cloud is made of concrete, steel, and silicon. It's millions of powerful computers, or servers, all packed into these enormous buildings we call data centers. Think of them like the invisible factories of our time, running 24/7, powering everything we do online. But, just like any factory, they come with a very real environmental price tag.
So just how big is that price tag? Let's actually put some numbers on this environmental bill, because they are, frankly, staggering. We're going to look at three things: electricity, water, and of course, carbon emissions. First up, power. Data centers in the United States alone use a whopping 1.8% of the entire country's electricity. Now, I know 1.8% might not sound like a huge number at first glance, but think about it. For just one single industry to take up almost 2% of a nation's energy pie, that is a massive amount of power.
And next, let's talk about water. See, all those servers generate an incredible amount of heat, and they need to be cooled down constantly. And that cooling process, it uses a ton of water. In the US, we're talking about 500 million cubic meters of water every single year. That puts data centers right up there in the top 10 of all industrial water users in the country.
And all that energy use, of course, has a carbon footprint. US data centers are responsible for about 31.5 million tons of CO2 emissions each year. To put that into perspective, that's 0.5% of the entire nation's greenhouse gas output, all coming from this one industry.
Okay, so we've seen what goes into these digital factories, but what about what comes out? Well, the waste really boils down to two main things: heat and hardware. Let's break those down.
Now check this out. On the one hand, you have waste heat. Pretty much every single watt of electricity that a data center consumes eventually becomes low-grade heat. And what happens to it? It's just vented out into the atmosphere. It's a huge, completely untapped energy resource that's just gone. Then on the other hand, you've got e-waste. Servers and other gear get replaced every few years, creating this mountain of old electronics, which is just full of both toxic stuff and really valuable materials.
And dealing with that e-waste properly is absolutely critical, because if you don't, the consequences can be really severe. You get toxic materials like lead and mercury seeping into our soil and water. If it's just dumped or burned, it releases all these dangerous pollutants into the air. And for people, direct exposure can cause some really serious health problems.
Okay, so that's the problem. And yeah, it's big, it's complex, but the story absolutely does not end there. Engineers and innovators are coming up with some pretty brilliant solutions. So let's dive into how they're actually engineering a smarter, more sustainable future for data.
Now, to really get the solutions, we first have to understand this one key metric. It's called PEU, or Power Usage Effectiveness. And put simply, it just measures how much energy is being wasted. It's the ratio of the total power going into the data center versus the power that actually gets to the servers doing the work. The goal here? Get that number as close to a perfect 1.0 as you possibly can.
And this comparison just perfectly shows the progress we've made. An older legacy data center might have a PUE of 2.0 or even higher. That literally means that for every 1 watt being used for actual computing, another entire watt is just wasted on things like cooling. But a modern, super efficient facility, it can hit a PUE of around 1.2. That means the waste is cut all the way down to just 0.2 watts. That's a game-changing improvement.
And look, this isn't just theory. Let's look at a real-world example. This is a data center in London that went through a huge efficiency makeover.
So, they started with a pretty rough PUE of 2.3. Remember, that means more energy was being wasted than was actually being used for computing. But by doing things like improving their air management and using cool outside air instead of just running the AC all the time, they managed to slash their PUE all the way down to 1.49. That is a dramatic improvement.
And the result of all that new efficiency? Well, besides being much better for the environment, it translated into $1.7 million in energy cost savings every single year. This just goes to show that being sustainable and being economically smart can and really should go hand in hand.
So that's how you tackle the electricity problem. But what about that other huge waste stream we talked about, the heat? Well, for that, let's head over to Finland for another incredible case study.
Instead of just pumping all that hot air from the servers out into the atmosphere, this project in Finland decided, hey, let's capture it. And just look at how well they did. They managed to capture and reuse an amazing 71% of the waste heat that the data center was producing.
So, what did they do with all that captured heat? They actually piped it directly into the local town's heating system, helping to warm homes and businesses nearby. It's brilliant. And the result, as this quote shows, was a huge 36% reduction in CO2 emissions for the heating network. It's this perfect example of turning one industry's waste into another industry's treasure.
Now, these innovations are amazing, but they're really just pieces of a much bigger puzzle. The ultimate goal here is to create a truly circular economy for our entire digital world, a system where absolutely nothing goes to waste.
And this applies directly to that e-waste problem. Instead of a one-way street from the factory to the landfill, we can create a loop. So, step 1, reuse and repurpose. Extend the life of old servers by using them for less important tasks, or by donating them. Then, when a piece of hardware is truly at the end of the line, we move to step 2, certified recycling. You partner with specialists who can safely get all the valuable stuff out, like gold and copper, while properly disposing of all the toxic components.
So, let's bring it all home. What are the big things to remember? First, data centers have a huge environmental footprint. There's just no getting around that. But, and this is a big but, we have powerful solutions, from making them way more energy efficient to reusing their waste heat. Third, we have to adopt a circular economy approach to deal with e-waste. And finally, we need supportive policies to make all of this happen a whole lot faster.
And that really brings us to the final big question. Our demand for data, for streaming, for everything digital is not slowing down. It is growing exponentially. We have the tools, we have the strategies to build a much more sustainable digital world. The real question is, can we put them into practice fast enough to keep up with our own incredible growth? The tech is here, but the race is definitely on. Thanks for tuning in.